This is the modern periodic table. 118 elements are arranged in the periodic table in a very systematic manner. There are some properties related to these elements which define the ways in which these elements react. Since the elements are arranged in a very well organized manner, these properties also follow some particular trends. Let's see how. One important property related to the elements is their metallic character. We know metals are those which can easily remove electrons to form the positive ions. So in the metals, sodium, it has 281 electrons, so it can easily lose the last electron to complete its octet. It loses one electron, so it has a stable electronic configuration 2,8. Similarly, magnesium has electronic configuration 2,8,2. It loses the 2 electrons and forms a stable electronic configuration 2,8, thus forming a positive Mg2+ ion. So metallic character is the ease with which the atoms lose their electrons. How does metallic character vary in a periodic table? Let's see. So we remember that atomic size decreases when we move from left to right in a period, and atomic size increases when we move from top to bottom in a group. So what happens in a period? We know that the atomic size is decreasing. Since the atomic size decreases, the outermost shell is very close to the nucleus. So to remove an electron becomes very difficult because the nucleus is exerting a very great pull on the outermost electrons. And therefore, the ease to remove the electrons decreases, and thus the metallic character decreases. Since the metallic character decreases, the non-metallic character increases across a period. Let's try to explain this once again. So we know from left to right in a period, the atomic number increases. Since the atomic number increases, the nuclear charge also increases from moving left to right in a period. This increase in nuclear charge tends to bring the outermost shell close to the nucleus. Hence, the atomic size decreases. As the atomic size decreases, the electrons are held very tightly to the nucleus, and therefore the ease to remove these electrons decreases. Since the ease to remove them decreases, so the metallic character from moving from left to right in a period also decreases. Okay, so now we have to move down a group in a periodic table. Down a group, we know that atomic size increases. The atomic size increases because of the increased number of shells which overweigh the increased nuclear charge. Metallic character, we know, is the ease to lose the electrons. As the size increases, the outermost electrons are away from the nucleus. Therefore, the ease to remove this outermost electron increases. As the ease to remove these electrons increase, so the metallic character increases, and so the non-metallic character on moving from top to bottom in a group decreases. So what happens in a group? Let's revisit. Nuclear charge on moving from top to bottom in a group increases. As the nuclear charge increases in a group, we also know that the number of shells increase successively. This increase in the number of shells overweigh the increased nuclear charge. The effect of the increased nuclear charge is that it tends to pull the electrons close to itself, but the number of shells increasing overweigh the increased nuclear charge, and so the atomic size on moving from top to bottom in a group increases. This increase in atomic size leads to the fact that the electrons are held loosely because the distance between the nucleus and the outermost shell increases, so the electrons are held loosely. Hence, the ease to remove them or to lose the electrons also increases, and so the metallic character from moving top to bottom in a group increases. So there are three elements: boron, aluminium and gallium. The one with the greatest metallic character is, let's see where do they lie in the periodic table. We have boron, aluminium and gallium. They lie in one group. We've just studied that on moving from top to bottom in a group, the metallic character increases. And so, on moving from top to bottom in a group, the metallic character increases. So, gallium has the greatest metallic character out of these three elements. So in a periodic table, when we move from left to right in a period, the atomic size decreases. Due to the decrease in atomic size, the ease to remove the electrons also decreases, and so the metallic character decreases. When we move from top to bottom in a group, the atomic size increases. This leads to increased distance between the outermost shell and the nucleus. So the electrons are held loosely, they can be easily removed, and so the metallic character increases on moving from top to bottom in a group.